Hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome to this tutorial where we will build an automated plant irrigation system using TDCI with Arduino. This project helps us manage real-time communication between a host PC and Arduino to efficiently control irrigation. So what is TDCI? So TDCI allows application running on a host PC to send command and receive the real-time data from hardware like Arduino. It simplifies communication between two, enabling seamless control of sensors and actuators in projects. So here you can see this host application. It may be a Windows or Linux, whatever. So here the host is sending a command, it is calling any hardware API calls. So based on that command, this TDCA target monitor will send the response via the serial communication. So this two seamless communication between host and target making this TTCA application on this RTOS concept. Okay, let's see the overview. This project uses an Arduino connected to a soil moisture sensor to monitor the moisture level of plants. Using TDCA, we connected a simulated RTOS environment to the real-world hardware, allowing us to control and monitor the irrigation process in real time. The system ensures plants are watered properly when it is needed, and improving water efficiency and automating the plant care. Our system consists of Arduino Uno controller and a soil moisture sensor which detect the moisture level in the soil and water pump to irrigate the plants. The entire setup is controlled via TDCA, allowing us to send command from a PC and get live sensor data back. So you can see these are the components: soil moisture sensor, which detect the moisture level in the soil. If the moisture level is below setting the threshold value, then the system activate the water pump to irrigate the plants. The control logic which decides when to water the plant and simulated in the RTOS on a host machine, allowing the developer to test and fine tune the irrigation process. So this is the microcontroller we are using here, and this is the water pump motor we are using here for irrigation process. So this TDCI establishes a communication between host system and target hardware. The host send a command to the Arduino to start or stop the watering based on the moisture data. The Arduino processes the command, turns the water pump on or off, and continuously monitor the soil moisture level. Using TDCA, developers can simulate various conditions such as dry or wet of the soil condition, and based on sensor reading, the system decides when to water and sending command to the water pump in real time. So the feedback loop ensures that when the soil reaches the desired moisture level, the system automatically stops watering. Okay, so this is how the system is works on. Okay, now let's see the coding part. Here we must include the TTCA.h header file because TTCA is the tool to connect any hardware target to the host PC via serial communication. So from beginning of the code, we should initialize the TTCA with our compute. My compute is 7, so based on your compute please use your one, and then the following Arduino code. So now I'm going to run this console, open with system editor. So here you can see that all the APIs, whatever pin mode, digital write, and the sensor value. So everything is coming based on the API result. So I can show you. So here you can see clearly that um, pin mode is success and analog read pin, and this para value, this is the sensor data. So based on this sensor data, it is saying that my soil is dry and motor should turn on. So meanwhile, when you see, when I am trying to detect the sensor, it just goes on 0 and my soil is wet and motor get turned off. So this is how the TDCA helps to work any hardware target via the serial communication to our host PC. Let's see how the hardware setup is doing. Coming to the project setup, so here I'm using Arduino Uno board and relay control, soil moisture sensor, and then water pump. So I gave the required connection for this project setup. Now you can see the red LED is glowing on relay. Whenever I started running this, you can see that green LED also getting on for we can know that the relay is working. And then similarly, when I am trying to detect this soil moisture sensor, you can see that one of the LED is also glowing on. So I place this water pump in the water. You just think this is a water tank. This pipe you can place on the flower pot so that the system gets watering. And then this soil sensor you should put on the flower pot. So instead of here I'm just using to place on this water, because I'm not using a flower pot, no. So I'm placing here to make the circuit connection. See, when it detect the moisture, the LED is glowing, so that I can know that the sensor is working. So similarly, after running the project, you see the green color LED is switched on the relay, which means the water pump is running. And whenever I'm detecting the sensor, you could see that the green color LED is turned off. So which means the motor getting turned off. When I remove, it's turned on. So the host system is controlling the control logic such as when to activate the water pump based on the soil moisture threshold. So host is sending command to the Arduino to turn the pump on when the sensor detects the soil is too dry. So the Arduino controls the pump and water the plant, continuously monitoring the soil moisture level. So the Arduino send moisture data back to the host and adjusting the irrigation settings and ensure the system is functioning efficiently. Okay, now I'm trying to run this code. You can see that my water pump motor is running and the water is coming out. So this is the pipe where we kept on the flower pot so that it is watering the plant whenever the soil sensor is dry state. So when I'm trying to detect the sensor at moisture level, so here my motor is stopped running. So this is what my soil sensor is getting wet state and my motor pump is turned off.
and when I'm again remove from the wet condition, and then you can see that my motor is running again. So in this video we saw how TDCI facilitate real-time control and monitoring of a plant irrigation system using Arduino. The system can be adapted for various other automation tasks, making it a powerful tool for real-time projects.
So that's it. Thanks for tuning in. If you found this helpful, stay connected for more RTOS related videos. Bye.